Last class we have discussed about the heating curve and cooling curve, and before that the types of electrical drive and then the basic components. So till now, any doubt? Any doubt in the last class? Say yes or no.
You may post message in the chat box.
No, no, ma'am. Okay. Then the next topic is load condition in motor. So already said, while selecting a drive for motor, we should consider the first thing is speed torque characteristics. So uh, it depends upon the speed and torque, my motor characteristics, and then the drive, the characteristics will be varying. So first condition we have to choose the load requirement depends upon the speed and torque. This is the main thing we have to do while selecting a drive for motor. So the load requirements either in speed control and torque control. So this is the classification of loads. So first of all, what is mean by load? What is load? All of you. What is load? I was saying in the last 5 class, what is mean by load? I'm asking with you only, what is mean by load?
Weight connecting with the shaft.
Yes, anything you can connect with the help of the shaft to the motor. So in domestic application, we can say fan is a load, and then grinder, mixie, whatever you are seeing, it is called load. Already said the same way. Depends upon the load. In the torque and speed, we have related with that. Here we have classified into 4 types. So before that, you should know the what is mean by torque and then load torque. You should know the fundamental torque equation. I'm going to write in my A4 sheet. Please note it down. This is my fundamental torque equation. Here you may know about the what is torque and then load torque and then angular velocity and all.
It's not visible there, madam. Yeah, you have to bring it little bit down.
Okay, ma'am. Once I finish, it will be clear, I think. Pin my name, another Vidyalakshmi R. And then my A4 sheet will be visible. This is the fundamental torque equation. Pin my name, another name. I have connected with 2 devices. So I have pin another name. This is the fundamental torque equation. Now it is visible.
Yeah, it is clear now.
So a motor generally drives a load through some transmission system. While the motor always rotates, the load may rotate and may undergo a translational motion. So the motor load system by an equivalent rotation system is shown in the figure. So there here on torque is going, it's called motor torque. The another torque is called load torque. Yes. Now my voice is okay, audible. Again, it is breaking.
No, it's clear. It's clear.
Okay. So normally have connected load with motor. Here there is two torque will be occurring. One is motor torque and another is load torque. So normally my torque and omega m is nothing but angular velocity of the motor shaft. It is in the same direction, and then TL is the opposite direction with respect to T and omega m. So while considering my motor torque and omega m, I can derive the fundamental torque equation. So before that, you should know the various notations we have used in the fundamental torque equation. First one is J. J is nothing but inertia of motor load. Inertia of motor load. And then already said omega m is nothing but angular velocity of the motor shaft. And then T is nothing but developed motor torque. And then TL is nothing but my load torque. This is the thing you have to know. This is the thing you have to know, the fundamental torque equation. Depends upon the inertia and the angular velocity, my torque equation will be varying. So from this I can write my T minus TL is equal to dt differentiation with respect to j omega m. See how I am deriving this equation means, because my angular velocity and inertia will be keep on varying. Yes, while rotating any rotational system, my angular velocity it not be constant for throughout the machine system. So it will be varying while rotating. My angular velocity and as well as my inertia is keep on changing. So in order to make that, I have termed as d by dt, which is mean change in time. So this is by the fundamental equation. Next step, I'm going to integrating with respect to j into omega m. So I'll change it as j with respect to d omega m by dt, and then omega m with respect to dj by dt. I simply multiplying with respect to j with respect to d omega m and then omega, and then I have differentiating another term. Just UV method. The next one, so normally for constant inertia, I have choose my Tj by dt equal to 0. So I take it as this term will be 0. So it will be cancelled here. So my equation will be T minus TL is equal to J into d omega m by dt. So I need my developed torque only. So it will be varying. It depends upon the TL by J into d omega m by dt. This is the fundamental torque equation of the drive. I'm repeating once again. So before going to the load torque and then load, you should know the what is mean by developed torque and then load torque. Here I have take the example for motor load system. I have connected motor with respect to shaft. I have connected the load. So the load maybe you can choose as depends upon your application, fan, grinder, whatever maybe you are seeing your domestic application. I can say it is a load. So what will happen? On changing with respect to time. So I have derived from this term nothing but T minus TL is equal to d of dt by j omega m. Yeah, because it depends upon the j and omega only, my T and TL will be varying, because the torque is depends upon the inertia and angular velocity. So that's why I keep it as T minus TL, which is equal to D by dt of j omega. The next one, I'm going to integrating with respect to the U and V method. So first one, I have integrating J with respect to d omega m plus omega m and dj by dt equal to 0. For constant drive, I have choose my constant inertia, which is nothing but my dj by dt equal to 0. So for that, I have rearranged that. It will be cancelled. This term will be cancelled. So my dl equal to j into d omega m by dt. I need developed torque only. So T is equal to dl plus j d omega m by dt. This is my fundamental torque equation. Any doubt in it? Any doubt? Have you all copied? Shall I move to the next topic? Yes. The next one, classification of load torque. So please note it down. Classification of load torque. It is classified into two types. First one is active load torque. I have written this short term T. And the second one, passive load torque. So it is classified into two categories. First one, active load torque. The second one is passive load torque. So what is meant by active load torque? Any guesses? Why I am classified into active and passive? Yes.
மேம் ஆக்டிவ் லோட் டார்க் அப்படிங்கிறது வந்து லோடே வைக்காம மோட்டரோட டார்க்கை மட்டும் சொல்றது மேம். பாசிவ் டார்க் வந்து லோடோட வச்சு எவ்வளவு டார்க் வருதுன்னு சொல்றது.
Is it so? No, it's not clear. It's okay, you have tried. As I already said, a low torque, when it is low torque occur, why I'm saying it's low torque, depends upon the load, the torque will be occurring. So without load, I cannot say it's a low torque. I can say it's a developed torque. So the load torque, the name itself, it has some load. Yes or no? So load torque is nothing but which have the potential to drive the motor and under equilibrium condition is called active load torque, which means this load torque usually retain the sign when a drive rotation is changed. For example, I have taken the elastic body. See, whenever I'm rotating or changing, it's come to my original position. Yes. For rubber, you take the example for rubber. If I'm pulling out or whatever, maybe I have rotated or whatever, maybe it comes to the original position. So the same way here, the active load torque, whenever the rotation may change or because the load torque will be keep on rotating. So this type of load torque, whenever the position or whatever the rotation will be changed, when again it will come to the original position. It come to the it retain the sign. It cannot it won't change the sign. It will be in, if it is my load torque, the particular load will be positive. Whatever may have rotating, that keep on changing, again it will come to the original position, which means the sign will be same. This is called active load torque. For example, I have set the elastic body. See, whatever we are doing due to tension and compression and torsion undercone, whatever maybe we have giving to the elastic body, again the elastic body is come to the original position. The same way, active load torque, the drive of the motor under equilibrium condition, whatever may be, it comes to the, it retain the original sign. If it is positive, whatever the changes may undergo, again it comes to the original sign, which means positive means it will be keep on in positive sign only. It retain the main, it is the retain the sign whenever the drive rotation is changed. That is called load torque. Please make an example for elastic body. You have to write down the example because while thinking active load torque, if you think the elastic body, you should know, you have to know that load torque is written the change. That's why I said, please make a note of the example.
Ma'am,
Yes, Rajvarshan.
could you please give some other examples, ma'am?
That is the best example, I think.
Okay, ma'am. Elasticity is
Elastic
one
body.
example, ma'am, but I need other examples, ma'am.
Okay, I will give in the last 10 minutes.
Okay, ma'am.
Okay. And then passive torque. The passive torque is nothing but the opposition of the whenever the load torque which always oppose the motion and change the sign on the reversal of motion is called passive load torque. I'm repeating once again. Load torques which always oppose the motion and change the sign on the reversal of motion. That is called passive load torque. What is meant by active load torque? Whenever the drive rotation is changed, the load torque usually is retained by a sign. So whatever may undergone, it retain the original sign. That is called active torque. But passive torque, while it's rotating, while whenever the opposition of motion occur, it change the sign according to the reversal of motion. That is called passive load torque. It is example for passive load torque is cutting machine. I'm repeating once again. தமிழ்ல சரி 2 நிமிஷம் மட்டும் சொல்லித்தரேன். ஆக்டிவ் லோட் டார்க் அப்படின்னா என்னன்னா, என்னோட ஏதாவது ஒரு லோடு இந்த லோடு என்ன ஆகும் அப்படின்னா, இட் மே அண்டர்கோய ரொட்டேஷன் சேஞ்ச் ஆகும்போது இட் வில் பி கம் அண்டர் பாசிட்டிவ் அண்ட் நெகட்டிவ், 2 சைடுமே சேஞ்ச் ஆகும். ரொட்டேட் ஆகும்போது எல்லா சைடுமே ரொட்டேட் ஆகும். கரெக்டா? மேலே அதாவது பாசிட்டிவ் சைடு போகும், நெகட்டிவ் சைடும் போகும். அப்படி போகும்போது ஆக்டிவ் லோட் டார்க்கா இருந்துச்சுன்னா இனி எவ்வளோ ரொட்டேட் பண்ணாலுமே அது வந்து ஒரிஜினல் சைன், அதாவது இப்ப பாசிட்டிவா இருக்குது இல்ல என்னோட இது நெகட்டிவ் அப்படின்னா என்ன பண்ணாலுமே அது ஒரிஜினலோட சைன் அதோட சைனுக்கு வந்துடும். சைன் மீன்ஸ் இட் இஸ் பாசிட்டிவ் ஆர் பாசிட்டிவ்ல வந்துடும், இல்லாட்டி நெகட்டிவ்ல வந்துடும். ஃபார் எக்ஸாம்பிள் எலாஸ்டிக் பாடி சொன்னேன். எலாஸ்டிக்கை நம்ம என்னதான் இழுத்தாலும் என்ன பண்ணாலும் என்ன ஆகும் அப்படின்னா அது மறுபடியும் அது ஒரிஜினல் பொசிஷனுக்கு வந்துடும். ஓகேவா? அதே மாதிரிதான் ஆக்டிவ் லோட் டார்க் என்ன அப்படின்னா என்னதான் நீ ரொட்டேட் பண்ணாலுமே அது கீப் ஆன் அதோட சைன் என்னவோ பாசிட்டிவா இருந்தா பாசிட்டிவ்லயே இருக்கும், நெகட்டிவ்னா நெகட்டிவ்லயே இருக்கும். எவ்வளவு ரொட்டேட் பண்ணாலும் என்ன பண்ணாலும் அதோட ஒரிஜினாலிட்டி சேஞ்ச் ஆகாது. தட் இஸ் கால்ட் ஆக்டிவ் லோட் டார்க். தென் while talking about the passive load torque, நீ ரொட்டேட் பண்ணும்போது அதோட சைன் சேஞ்ச் ஆகும். ஏன்னா ரொட்டேட் பண்ணும்போது என்னோடது என்ன ஆகும், என்னோட மோஷன் பாசிட்டிவ் போகும், நெகட்டிவ் போகும், ஃபார்வர்ட் ரிவர்ஸ் ஆகும், ஃபார்வர்ட் ஆகும். ஸோ அப்போ என்ன ஆகும் அப்படின்னா ரொட்டேட் பண்ண என்ன ஆகும் அப்படின்னா என்னோட சைன் சேஞ்ச் ஆகிட்டே வரும். தட் இஸ் கால் பாசிவ் லோட் டார்க். அதுக்கு எக்ஸாம்பிள் கட்டிங் மெஷின். ஓகேவா? Is it clear now? Is it clear? Okay. Yes. The next one, the characteristics of different type of loads. So now pin my name, another name, Vidyalakshmi R. So there I have described about the classification of load. So the first one, please note it down. Please copy the 4 types. First one is torque depend on speed, and then torque is linearly dependent on speed, and then torque proportional to square of the speed, and torque is inversely proportional to the speed. Yes? Now pin another name. I have going to draw the graph for the four types. From this graph, you can understand what is mean by the torque dependent on speed, and then torque is linearly dependent on speed. Please pin my another name I have drawn in the A4 sheet. For the first one is the torque dependent on speed, or another name is constant torque. The another name is constant torque type load. The another name of torque dependent on speed is nothing but constant type load. So I'm going to draw the graph for this type. Is it visible? Now it is visible. Arvind, it is visible? Okay. This is the first type of classification of loads. The torque depends on speed. Another type is constant torque type load, which means the most of the working machines that have the mechanical nature of the work, like shaping and cutting and grinding, require constant torque. So which means irrespective of speed, whenever I'm changing my speed, I need a constant torque. So for this condition, I have go with the torque dependent on speed or constant torque type speed load torque. So this is the example. Please note it down. So whenever I am changing the speed, I need a constant torque. This is the one type of classification of load. Not always the load is depends upon the torque. So it's in sometimes we need torque is linearly dependent, and then it's square of the speed, and then inversely proportional to the speed. I will say the example, then you can understand. I'm repeating once again. The first one is constant torque type load. Here, whenever I'm changing the load, I need a constant torque. So for this condition, I have used this type of constant torque type load. So where I am using this type of load means I'm shaping machine and cutting machine and grinding. There I have used this type of load. I'm repeating once again. Please note it down. Shaping machine and then cutting and then grinding. There we can use this type of load. Yes. That's why I have drawn the graph like this. Whenever I'm changing the speed, I need a constant torque. So it will be giving the constant line. Yes? Yes or no? Have you all understood? Have you all? Is any doubt in it? Any doubt? Yes, the next one is torque is proportional to the speed. The second type is torque proportional to the speed. The graph itself says whenever I'm changing the torque and speed, what will happen? If I'm changing the torque, it is linearly varying to the respective to the speed. So I'm repeating once again. If I'm varying the speed, it will be linearly, this is called linear curve, a curve which is passing through the origin, which means whenever my graph or my curve will enter to this origin, zero origin, that is called linear graph. So if I'm varying with respect to torque, what will happen? My torque curve will be linear with respect to my speed. This is my torque proportional to the speed. Whatever I am changing to the input, it will be affect on to the output. So torque is directly proportional. If I am increasing my torque, what will happen? My speed will be changing. For this condition, I am increasing speed up to 1. So what will happen? It will be varying. And then 2, and then it will be varying. So it is linearly varying. This type of we can use in the generator side. This type of load we can used in the generator type. Already I have talked about the generator and motor in the basic introduction class. So torque is proportional to the speed. In generator side, we can use this type of load torque. Is it clear? Is it clear? All of you? All of you? Yes. And then our next type, torque is proportional to square of the speed, which means torque is directly proportional to omega square. This we can use in the fan type. Normally you can see the ceiling fan. In order, if I'm going to increase my speed, I have to rotate the regulator. So I'm rotating the regulator, which means what is meant by torque? What is torque? Anybody? Anybody, what is torque?
Twisting force.
Yes,
Twisting force.
the same I have done in the regulator. If I'm twisting or rotating, what will happen? My speed will be increasing. Here, the fan type, the speed will be increasing square of the speed. So if I'm increasing the, for example, if I'm increasing speed is 2, so the torque will be 4 times. So 4 times it will be increasing. The speed will be increasing 4 times. Yes? Yes or no? If my rotational force will be 2, if I am increasing 2, the speed will be square of the speed. So 2 means it will be get the output is 4. For this graph, it will be like this. So example for this type of load is fan, and then rotary pumps, and then compressor, and then ship propellers. I'm repeating once again. The torque is proportional to square of the speed. If I'm increasing the torque by any term, any constant type, I already said, if I'm increasing my torque with respect to 2, what will happen? My speed will be 2 squared, which means it is square of the speed. If I giving the less torque, it will give the square of the speed, which means the square of the output. So this is what we have used in the fan, and then rotary pumps, and then compressor and ship propeller. And the last one, torque is inversely proportional to speed. And then the last one is torque inversely proportional to the speed. This type of load torque we can use in the cranes and then lathe and then milling machine and then steel mill. Here my graph will be like this. Torque is inversely proportional to the speed. In some cases, if I am increasing my torque, the speed is inversely proportional to the torque. So if I'm increasing means the speed will be decreasing. So it is called inversely proportional. So based on this type of load torque, we can choose, depends upon our application. So here this type of load torque we can use in the lathe and then boring machine and then milling machines. Yes. This is the classification of load torque. I'm repeating once again. So listen once again. So depends upon the torque and speed characteristics. It is classified into 4 types. The first one is constant torque type load, and the second one torque proportional to the speed, and then third one torque is directly proportional to the square of the speed, and then fourth one torque is inversely proportional to the speed. It depends on our application. We can choose the types of load. The first one, constant torque type load, is nothing but whenever we are changing the speed, we need a constant torque. The constant torque irrespective of the speed. So even though I keep on changing my speed, I need a constant torque. So where we are using this type of load torque means it is used in the shaping and cutting and grinding machine. And then second one, torque is proportional to the speed, which means it is linearly variable. If I am changing the torque, whatever we are changing depends upon the linearly, the speed also will be varying. So linear is nothing but a curve which is passed to the origin. This is called linear. So whatever we are changing, it is linearly varying with respect to speed, is called torque proportional to the speed. This type of load torque we have used in the generator type. And then third one, torque is proportional to the square of the speed. So here already said fan is the good example for this type of load. If I'm increasing the torque, it will be that speed will be increasing twice the time. So is the example for the third one is fans. And then fourth one, torque inversely proportional to the speed. If I'm increasing this torque, speed will be decreasing. So the vice versa. So this type of load torque we can use in the boring machine and then milling machine and then lathe. Also depends upon our application, we can choose this type of load torque. Yes. Any doubt in it? Any doubt? No? And then pin my another name. The PPT is visible. So this is what I said in the before. So please note it down. This is the classification of load. Till now, any doubt? Yes. Till now, any doubt? Any doubt? Now the next one is classes of motor duty. The same which I said before. The class of motor duty is another important topics in the module 1. Again, it is go with the torque and speed with respect to heating and cooling curve. Here we can attain the steady state temperature. Before that, going to the motor duty, should know the what is meant by steady state condition and all. So already said, while choosing a drive, we should consider the speed and torque. So based on this, we can choose the load, torque and all. So whenever I need a steady state condition, that condition, the load torque will be equal to motor torque. That I can say it is a steady state condition. Please note it down. Steady state condition is nothing but my motor torque, which is equal to load torque. Please note it down. Have you all? This is called steady state condition. Whenever my motor torque is equal to load torque, the time I can say it is a steady state condition. So depends upon the speed and torque and then heating curve. I can classify it into my motor duty into continuous duty, short time duty, and intermittent periodic duty, and intermittent periodic duty with starting. And then there are 8 types as there. Again, with the help of the graph, I can easily say what is meant by continuous duty and short time duty and intermittent periodic duty. Please note the 8 types of motor duty. I can explain one by one. Till now, any doubt? Till now, any doubt? Okay. Please note it down. Continuous duty. Shall I move to the next topic? Have I noted down? I think you have completed. A move with the continuous duty. This is called continuous duty as nothing but electrical motor operation at a constant load torque for a duration long enough for motor temperature to reach the steady state value, which means is another name is constant torque drive. So whenever here the T term, it is in x-axis, the T will come here. At the same way here also T, we can vary with respect to time only. So the drive will operate continuously for a constant torque. So TL is nothing but load torque. So the continuous duty is nothing but I can continuously running my motor with the constant load torque and motor torque. This is called continuous duty. So I can draw the graph with respect to time and then load torque the same way, time and temperature. This is the continuous duty. I'm repeating once again. So this type of duty I can occur in the constant torque. So if I'm increasing my temperature or whatever maybe, or if I'm increasing my speed and also I need a constant torque. So this is called continuous duty. I'm running my machine in continuous manner. It attain a constant motor torque and then constant motor loss operation. So this is called a continuous duty operation. I can draw the time with respect to TL. It approaches a constant. The same way, time with respect to theta, it will be linearly varying. After that, it reaches the constant temperature. This is my continuous duty, which means there I can use my drive in the continuous manner. I cannot stop at any point. Once my all work is done, then only I can switch off my drive into the rest position. Till now, I can continuously, I'm working my load torque. So there I can get the constant load, a constant load torque. Have you got my point? What I'm saying? Have you all got my point? Yes? Have you all got my point or not? Any doubt? Any doubt? I'm asking with you only. No. Okay. Okay. So this is the example for continuous duty: paper mill drives, compressor, conveyor, centrifugal pumps, and fans. See, while operating, till I switch off the drive, till up to rest, it will be continuously gives the constant load torque. This is called continuous duty. Yes, this is the first classification of motor duty. And the next one is short time duty. So this type of operation is nothing but I can use for the particular time. So for this I can say here the load torque, I can run my drive for the short time. So for short time, what will happen? I can turn on and then off. So it will be a particular short time I'm using this drive. So that's why it is called short time duty. So the temperature, what will happen? When it's starting, my temperature is keep on varying, and then once it's switched off, it will come to the cooling curve. So it while running, it started to increasing, and then while coming to the rest, my temperature will be reducing. So this is the temperature graph. This is my short time duty. I'm repeating once again. This type of duty I can use for the small time application. So it is used to, it will be run on a particular time. For particular time, I can start, and then next time, for the next period, the drive will move to the rest position. So what will happen to my temperature rise curve? So while starting, it will be started to increasing, and then till now, till TL, my graph will be increasing. Once I switched off, what will happen? My temperature will be reducing. So my graph will be reduced like this. This is called short time duty. For example, for short time duty is crane drive, because the crane drive we cannot use all the time. Once we can pick something, you have to take some rest. After that, we have to move. So we need a particular rest period. So which means we can run only for the short time. So the crane drive is the best example for short time duty. Any doubt for short time duty? Any doubt? Is it clear or not? Shall I repeat once again? All of you?
Ma'am.
Okay. Short time duty is nothing but we can run the drive for particular time period, short time. So there we can use for shorting and then running. After that, I have moved to my drive into rest position. So particular time for this, while seeing this graph, for this period only I can run my drive. After that, it will come into the rest position. So while drawing my temperature curve, up to this, my temperature will be keep on varying. So that's why the graph will be like this. This means, please pin my another name. See my A4 sheet. There I can explain. This is my short time duty load torque curve. So this period I'm going to run my drive this period. So what will happen to my temperature? Up to this, my temperature is keep on varying. Yes, are you agree my point? After that, what will happen? After that, my drive will be in rest position. There is no temperature. So my temperature is keep on falling like this. This is my theta. Yes, now you can understand what I'm trying to say. This is the short time duty curve. For example, you can take crane drive. For crane, we have used for the picking and then dropping something. If I'm picking, I can use for the short time. After that, it will be in rest position. After that, only I can use to track the other thing. The same way. So, for example, I can take for mixie also. For I can use mixie for only short time duty only. So, if I'm using my mixie in short time, so the temperature will be keep on increasing. After that, I'm going to take it as a rest period. I'm going to switch off my mixie. What will happen? My temperature will be reduced in the this manner. This is called cooling curve. This is my heating curve. Now you all understood what I'm saying? Yes? Have you all understood? Yes or no? So my voice is audible? Yes. So now pin my another name. There, the example of, see, the drives for household applications, because in household application we can use our appliances for only short time period. So this is the best example for short time duty. You can choose it as mixie. Yes. Now we all understood. Please note it down, the example. Then only you can understand what is meant by short time duty. Yes. Yes, shall I move to the next one? Yes. Must say yes or no? Yes, the next one is intermittent periodic duty. Please listen. So intermittent periodic duty is nothing but it consisting of period of running at constant load torque under rest period, which means it's continuously working. There, in for short time duty, we can use for only short time period, but here we can use continuous rest period manner. So while seeing this graph, I can start the drive. After that, I give some rest. Again, I have started. Again, I give you some rest. So depends upon that, my temperature rise will be varying. Up to this, my temperature is keep on increasing. Then once the rest period is coming, what will happen? It will come to the rest position. After that, it will be temperature rising and then dropping, rising and dropping, which means intermediate periodic duty. We can switch on for period time. We have started some period. After that, we have to come to rest position. Again, I have started the drive. Again, I will give some rest. Again, I started my machine. So this is the example for intermediate periodic cutting duty is cutting and pressing and drilling machine. So there, pressing and drilling machine, we cannot continuously run my machine. We need some rest. So there we can use the intermediate periodic duty. Yes. Yes. Have you got my point? Have you all got my point? If you draw the curve under a TL, the same which I draw before, it will be look like this only. Up to this, my graph is linearly increasing. Once it's come to the rest position, what will happen? My temperature is false, so it will come to the cooling curve. Again, it is heating curve. Again, it is cooling. Again, heating. Again, it's cooling. That's why my graph will be like this. Yes? Have you all understood? Please note it down the examples. There only you can easily say what type of periodic and all. Yes. The next one. Have you all copied the diagram? There here in exercises you have to write time t. Please note it down. I missed the time here. So in exercises you have to mention the t here. Everything we have to draw with respect to time only. Please make it down, note it down. T comes in the x-axis for all the graphs. Yes? Shall I move to the next one? Yes? The next one is intermittent periodic duty with starting. Here, in before that graph, we cannot consider the starting and breaking and all. Yes or no? Here I didn't say the word starting and breaking, but here while drawing the temperature curve, my starting and breaking play a vital role, because here I'm starting the machine, there I have running, after that only it will come to the rest position. So throughout my condition, my temperature curve will be depends. I'm repeating once again. Before 3 types, I didn't say I only talked about the starting period and then stop period. I didn't mention the running period and then breaking period. So here they have set the intermediate periodic duty with starting. So while starting, this is my starting time. After that, this is my running time. This period is running time. This is nothing but this is my rest period. So while draw the temperature graph, up to this it's play a vital role. It is starting, after that it's running. Once it reaches the rest period, then only my graph it fall to the 0. After that it started to increasing. Please pin my another name. If I'm drawing it once again, then only you can understand. Pin my name. This is my starting period. This is my running period. This is my rest period. So I have draw with respect to time and then TL. TL is nothing but load torque. So I'm going to draw the graph with respect to T and theta. Depends upon the starting and running, I can draw my graph. So I have to drag here. Yes. Here also. And then here also. So what will happen? My graph will be linearly increasing, and then it will be increasing, and then it will be decreasing, which means I'm repeating once again. Before all the 3 types, I didn't say about the running period and then breaking period. I have said only the starting and stopping. But here I have talked about the running period also. So while this is called the intermediate periodic with duty with starting. So while starting, my temperature graph will be increasing, and then while running, what will happen? It started to increase, decreasing, and then while rest, it will completely go to 0, add some value. After that, I started my machine, it started to increasing, and then I had to start to rest. So you have to consider my cooling curve with respect to running period, which means the heating curve depends upon the starting period only. So that's why it is called intermediate periodic duty with starting. For example, for this duty is called metal cutting and drilling tool drive. There we have to start and then running. While running, my temperature will be going to reduce. Here also I didn't talk about the breaking. for the next duty, I can talk about the braking also. So based on the starting and braking and then running, we can classify the duty into 8 types. So some cases we have considered and some cases we may not consider. Depends on our application. It will be keep on varying. That's why I have said the examples. While seeing example, we can see easily what is meant by intermediate periodic duty and then short time duty and all. So for short time duty, if I'm saying Mixie's example, you can say easily I can start the machine and then we can use for the particular time. The same way for another type also, intermediate periodic duty. So while studying a motor duty, you have to memorize the example. Then only you can easily write what is meant by periodic duty and short time duty and all. So the name itself, it says the intermediate periodic duty starting. So we have to take the starting for a temperature rise. Is any doubt in it? Any doubt? Any doubt? Say yes or no? Next one. The next one is intermittent periodic duty with starting and braking. Again, pin my name. I have drawn the curve. Then you can easily understood what is meant by intermittent periodic duty with starting and braking. Please see by another graph. This is the 5th type of motor duty. Again, I am going to draw the graph. Here, the name itself that says the meaning intermittent periodic duty with starting and braking. This is my starting. This is my running. And then this is my rest period. Again, starting, running, and then it will be rest period. So this is my starting, and then it's running. This period is called braking, and this is my rest. Yes? Why no? All said no. Is it visible? Have you all draw my intermittent periodic duty with starting and braking curve? Have you all?
It's visible, ma'am. It's visible.
This is the 5th type of motor duty. So intermittent periodic duty with starting and braking. So from the name itself, what will happen? Please see the last graph and then say how it will be varying. In last graph, I didn't talk about the braking, but here I have talked about the starting and braking and then rest. What is mean by braking? Anybody? What is mean by braking?
Resting the shaft or stopping the shaft.
Pardon, I didn't hear your voice clearly. Say once again.
Resting the motor or stopping the shaft.
Yes, to stop the motor. To stop the motor, I can say it is a braking. So rest means we can. It simply is off condition. There is no running. There is in fully stop. Braking means we have to, while applying a brake, it need 2 minutes or 3 minutes to come into rest position. Yes. So that's why I have drawn like this. So intermediate periodic duty with starting and braking is nothing but the name itself. Up to braking, my temperature rise is there. Once it will come to rest position, it will be in a cooling curve. After that, again it will be keep on varying. Yes, I'm repeating once again. For this type of duty, you have to consider my temperature rise up to my braking. starting, running and braking, my temperature is keep on increasing. Once I switch off my motor, what will happen? It come to rest position. Then only my cooling curve will occur. Again, it will be repeating on. So this type of periodic duty, we have to consider the starting period, running period and braking period also for the heating time curve. The rest portion only the cooling curve take place. Again, the cycle is repeating on. There's nothing but already said. In some cases, we have to consider the starting and braking and running. In some cases, we have only talk about the starting period only. So based on our application, based on our drives, we can change the motor duty. Yes. So for example, for this drive is called mine host and then drives for electrical suburban drives and then machine tool drives. I'm repeating once again. As switch on pin on my another name, the PPT is visible now. So I have given so many examples. Please note it down. Drives for electrical suburban drives. So have take example for train. So train, what will happen? I'm going to start the train and then I'm running and then to stop the train. So till now my temperature curve will be keep on increasing. Once my train will be in rest position, my cooling curve will be 0. Again, while starting and then running and then braking, you have to, the temperature is keep on increasing. So this type of periodic duty, you have to consider the that a steady state temperature occurs only the starting, running and braking period also. You have to consider the three periods here. Yes? Any doubt? Say yes or no? Any doubt? Yes, any doubt?
What is mean the billet mean? Billet mean?
Billet mill. Once again. Is nothing but a rolling mill designed for the rolling of looms or incuts into pilots of squares and round cross sections, which means example lathe. We have cut it in the iron pieces into square and then round size. That mill is called billet mill. Okay.
Okay, ma'am.
Okay. The next one, continuous duty with intermittent periodic loading. So the last three types, 6, 7, 8, they don't have graph. I simply saying what is meant by continuous duty with intermittent periodic loading. Please note it down. Nothing but while running, my machine will run at a constant load, and then while period of running, it is no load. So load and no load. We have to talk about the loading condition and unloading condition. So there we have talked about the continuous duty with intermittent periodic loading. I'm repeating once again. Here I have talked about only the loading condition. The name itself says the meaning of the continuous duty. So here I'm talking about the periodic loading changes. Sometimes we are giving the constant load, or sometimes the load will be varying. So here we have talked about the loading period and then non-loading period, or constant load or no load. There my voltage, how it will be occurring, and then how my temperature and load curve will be occurring. There we have talked about the continuous duty with intermittent periodic loading. I'm repeating once again. Here I'm going to apply my load for running period. So running period, my load will be in constant. and then another period it will be no load. So I have talked about the no load and then load condition. That's why it is called continuous duty with intermediate periodic loading. There is no graph for this duty. Again, it's the example for continuous duties: pressing, cutting and shearing and drilling machine drives. Yes, have you any doubt? No doubt irka? No. And the next one is continuous duty with starting and braking. Here it is continuously running. There is no rest period. So the machine, the drive will be running at a without rest condition. அதாவது continuous run ஆயிட்டே இருக்கும். Starting, running and braking. Again starting, running, braking. There is no period of rest. That is called continuous duty with starting and braking. For example, for this drive is the main drive of blooming mill. I'm repeating once again. The continuous duty with starting and braking, this type of drive, it is done based on the starting, running and then braking. There is no period of rest. That means it will be continuously running. There is no rest period. So this is the continuous duty with starting and braking. The last one is continuous duty with periodic speed changes. Again, if I'm changing with respect to speed, I mean again repeating, I'll keep on changing my speed. Before and all, I have talked about the constant speed, because there we have applied the starting and running. We didn't talk about the speed, but here I'm going to change my speed. The speed will be varying. So what will happen? For different type of load, I can apply different type of speed. So, but in this condition, we cannot attain the steady state temperature, because what is my steady state temperature? Whenever my motor torque is equal to load torque, then only I can attain my steady state temperature. But here I keep on varying my speed. I cannot able to achieve my steady state temperature. Again, here no period of rest. For last two type of duty, I cannot talk about the rest period, because it's continuously working. That's why they have named as continuous duty with starting and braking, and then here continuous duty with periodic speed changes. So here the example for continuous duty with periodic speed changes is nothing but all variable speed drives. Any doubt? Any doubt? Please listen and quickly recall the classes of motor duty. Please see my PPT. Quickly revise the classes of motor duty. So the motor duty is nothing but based on our load torque and then starting and braking, it is classified into 8 types: continuous duty and short time duty and intermediate periodic duty. In some cases, we have considered the starting period and running period for our temperature rise. In some duty we cannot consider. Based on our application, the duty cycle and then duty will be varying. First one is continuous duty. Is nothing but we can run at a constant torque type, which means whatever may be happen, if I'm changing my speed and torque, whatever happen, I need a constant torque. So here there is a possible to attain a steady state temperature, because if I'm running at a constant torque, my load torque which is equal to motor torque. So here I can easily attain a steady state temperature. Steady state temperature and steady state load torque means a constant torque and constant temperature will be attained. While seeing the theta graph, temperature rise graph, I can say the machine will run at a steady state temperature, because it will be in constant temperature. The same way here it is constant speed. So in some motor, the continuous duty maximum we can use the continuous duty operation only. So for example, paper mill drive, compressor and conveyor and centrifugal pumps, we can use this type of continuous duty. Yes. The next one, short time duty. We can use this drive for particularly for starting and then braking. So what will happen? I'm taking an example for household application. I'm taking as a mixie. I am starting a mixie and then I have stopped the mixie. So I can run for a particular time period. So this is called short time duty. Again, I have talked about on the starting period, because we have we have used the mixie while starting and stopping and starting and stopping for a particular period. So this is the example for short time duty. Again, we won't talk about the running and braking condition here, because for short period we can start and stop. So there we can use the short time duty. And then intermediate periodic duty, here continuously we can on and off the drive. So for this, what will happen? Again, I have talked about the starting and then stopping. I didn't talk about the braking and then resting period here. So what will happen? If I am starting, again I need to give some rest. Again I'm starting the drive. Again I give some rest. Again I'm starting. Again I give some rest. So based on this, I can draw my temperature rise. Up to starting, the temperature is increasing. So heating curve. Again, once it will be in off condition, what will happen? Again, it will go to the cooling curve. Heating, cooling, starting, stopping. So based on this, it will be running. So this is the example. Pressing and cutting and drilling machine is the example for intermediate periodic duty, which means we can continuously on the drive and the after drive. And then intermediate periodic duty with starting. So here I have take the starting period only. So starting and running and then rest period. Till now I didn't talk about the starting period, start running period, but here I am talking about the running period. So what will happen? My temperature rise will be increasing up to my starting. While coming to the running period, it will be in off position. So it will move to my cooling curve. Again starting and again it will be cooling. This is my intermediate periodic duty with starting. The next one, intermediate periodic duty with starting and braking. Here I have drawn the graph in A4 sheet. Here you have to consider the starting, stopping, running and then braking. Up to braking, my temperature rise will be increasing. After that, once it reaches to rest position, then only my cooling curve takes place. Again, it will be increasing. Here, please note it down. We have to consider my starting, running and braking. From up to braking, my temperature graph will be keep on increasing. Once it will come to the rest position, then only my cooling curve will take place. For example, for intermediate periodic duties, suburban trains, and then continuous duty with intermittent periodic loading. Here I'm only talking about the loading condition. In some, it is nothing but constant load and load. So in some application, we can run the machine at constant load. In some condition, we can loading at no load. So this type of continuous duty will occur in the pressing and cutting and shearing machine. Again, it's nothing but the main, there is first point is very important point here. This type of operation consists of period of running at constant load and period of running at no load. This two is enough, more than enough to write about the continuous duty with intermittent periodic loading, and other things are not needed. So this is the main thing. We have to consider the loading period and no loading period. And then again, this continuous duty with starting and braking. So the machine is keep on running, starting, running and braking. There is no rest period. So continuous drive run that is called continuous duty with starting and braking. There is no period of rest is possible. And the last one, continuous duty with periodic speed changes. Up to 7 type of duty. I didn't talk about the speeds. Here I can talk about the speed. So if I'm changing the speed, what will happen? What will happen to my drive, and then how it will be working, and then how it continuously varying. It is all come under this type of duty, continuous duty with periodic speed changes. Again, there is no period of rest here. I'm going to run my machine up to continuously, and I can use my different type of load. So different type of load, I can the speed also will be differing. So it is all come under this category, continuous duty with periodic speed changes. The example for this duty is called all variable speed drive. You can take it as any variable speed drive. You can take three-phase induction drive or DC drive, anything. It is all come under the module 3. There you have talked. You can study about the what is means speed drive and all. There I can say what is mean by speed drive and all. So this is the last topic. This is the any doubt in it? Any doubt in it? Any doubt? No. So I will share a multiple choice question here. We have to answer. Till now I have talked about the heating curve, cooling curve, and then group drive and multi-motor drive, and then classes of motor duty. I have combined all, and then I have take on quiz. Please attend that. Then only I give attendance today based on your response.
Ma'am,
Yes.
continuous duty ல மட்டும் ஒரே doubt ma'am.
என்னமா ஒரு நிமிஷம் இல்ல காப்பி பண்ணிக்கிறேன்.
Okay.
Attend this quiz. Please see in the chat box. Attend the quiz now. Yes. Who asked doubt?
Ma'am,
Yes.
Ah.
No doubt.
மேம் டெம்பரேச்சர் எப்படி மேம் கான்ஸ்டன்ட் டெம்பரேச்சர் அச்சீவ் பண்ண முடியும்? மிஷின் எவ்வளோக்கு எவ்வளோ ரன் ஆகுதோ அவ்வளோக்கு எவ்வளோ டெம்பரேச்சர் இன்க்ரீஸ் ஆகும் மேம்.
Yes. But in constant ஒரு நிமிஷம் நான் ரெக்கார்டிங் ஆஃப் பண்ணிட்டு வந்துறேன். டெம்பரேச்சர் எப்படி வேரி ஆகும்னு நினைக்கிறேன்?
இல்லை மேம், ஒரு மிஷின் ரன் ஆகிட்டே இருக்கும்போது அதோட டெம்பரேச்சர் இன்க்ரீஸ் ஆகிட்டு தான் மேம் இருக்கும்.